Hello, Abscissa here to help you out with your logarithmic equation questions. For this video, I'm going to assume you already have some knowledge of logarithms and don't need me to go over exactly everything with you. But before we jump into this video, let's touch some bases. Parts of a logarithm. Logarithms have a bunch of moving parts that you're going to need to grasp in order to solve them. The first of which are arguments that come right after the logarithm and the base. They are the numbers to which the logarithm is being applied. Keep in mind that I have color-coded a lot of these elements throughout the video in order for you to kind of keep things straight. Moving on, the base is the small number right next to the logarithm that is usually understood to be e or 10, though it can be different things. It is the number that is raised to an exponent or power in order to achieve the argument. The coefficient, or multiplier, there's a couple names for it, is the number in front of a logarithm. It is moved using the power rule, where it becomes the power to which the argument and any existing exponent is raised. You'll see what I mean in a little while. Finally, an exponent is a number to which a number or given expression is to be raised. It is usually attached to the argument. Now, with the knowledge of each part of the logarithm, let's discuss logarithmic properties. And there's a few. Starting us off, the product property states that the sum of two logarithms is equal to the arguments of the logarithms multiplied and set to the same log. The quotient property states that the difference of two logarithms is equal to the arguments of the logarithms divided and set to the same log. And finally, the power property states that the product of a number and a logarithm is equal to a log of the same base set to the power of the multiplier or coefficient. I will be referring to these properties throughout the video, so if you ever get confused, just pause the video, remember where you're at, and scroll back and read it again, because it is complicated until you get it, and then it's not, but that's with everything, isn't it? Now that we remember all that, or just know it for the first time, let's jump into problem 1, logarithms on both sides of the equation. As the title implies, there'll be logarithms on both sides of the equation. Now, what we want to do first is we want to move that coefficient, and apply the power rule and get it away from affecting and multiplying the logarithm, because what we're wanting to do here is we're trying to condense everything on the left side of the equation into one logarithm so that we can set the argument of that new condensed logarithm equal to the logarithm on the right side of the equation, so we can solve for the x that's in the argument. You'll see. Just follow with me. It's just as bad as it sounds. It's not worse. I'll tell you that. Really what we're trying to do is condense everything so we can start moving things around. Step 2. Rewrite the first two terms into one logarithm using the product property. Remember to distribute out and follow regular multiplication rules inside of the logarithm there when you combine them using the product property. Or practically any property, just follow normal rules. And if you lost it, just in case, here's the equal sign. I know there's a lot of numbers in there, so yeah, there it is. Hello! Here you can see the point of us combining everything on the left side of the equation is because in step 3, since both of the arguments are being applied to the same logarithm and base, you can set the arguments equal, which is practically just stripping both sides of the logarithms and just solving it like a regular equation. A regular solve for x equation. Step 4, isolate x by subtracting 64 from both sides. Divide both sides by 96 to get x alone, and then you should have your answer. In this case is x equals negative 7 over 12. Moving on, problem 2. Logarithms on one side of the equation. Step 1, again, you want to apply the power property to the second term. You never want to leave it being multiplied by something, because that just gets all messy. And again, it's not what it's a rule. Just do it, okay? Step 2, because they're subtracting from each other, both of the logs, you want to apply the quotient property to the first two terms to create one logarithm. Step 3, convert the equation from logarithmic form to exponential form. Now that everything's together, you can quite easily do this. In case you forgot how to set something into exponential form or you don't know yet, do this by setting the base of the log, which is 3 in this case, to the power of the constant, which is 9 in this case. Then set 3 to the 9th, or the new term, equal to the argument. Now, as you can see, it's more to a manageable equation. You don't have any more logs anymore, and I illuminated x because we can just solve like normal practically. Solve for x by reversing the division of 7x by multiplying both sides by 1024, or 4 to the 5th, if you kept it that way on your paper. And divide that really large number by 7 to get x alone, and you should have your answer. In this case, looks ridiculous, but it's right, and I want to expose you to ridiculousness. So if you ever see it on a test or something somewhere that you don't, just doubt yourself because it looks ridiculous, because I find I do that a lot. So yes, that is the correct answer. Yes, it hurts to look at, but there it is. Yippee! Finally, the last problem we'll be dealing with today is natural logarithms. They're really similar to just regular old logarithms, but they've got a few different things about them. But it's practically the same thing, same properties still apply, and you shouldn't get too confused. Step 1, apply the product property. We don't have a coefficient of any type, so you can just keep on moving on. And remember to multiply that out between the terms, or the one term in this case, which is 7x. And like we saw in the first problem, because both of the arguments are being applied to natural logarithms, you can set the arguments equal to each other and solve like a normal equation where you're finding x. I didn't illuminate anything in this this problem, just in case if it was distracting for you. I wanted you to have at least one where nothing was going on except for just black ink on paper. Step 3, square root both sides of the equation to get rid of the square on the x. Remember to do your favorite thing and rationalize the denominator. Then do your most favorite thing, which is check for extraneous solutions. Don't ever forget to check for extraneous solutions. You want to think that all the work you did mattered. Well, it might not, so you know what I mean. In this case, only the positive form of the answer worked, because if you put in the negative version, it would have made the log or the natural logarithm negative, which you cannot do. So if you ever get an answer and you plug it in and it makes the log negative, you can even put it in the calculator. It'll go error. So it won't work. So we only have one solution here, which is 2 times the square root of 7 over 7. A few things to keep in mind or takeaways from this video, but common logarithms, or log, they're expressed as log, and natural logarithms, which is ln, not in, okay? Because I got confused when I started. It's ln, cannot be used interchangeably. They cannot. They're different. One, common logarithms have different bases, where natural logarithms can only have a base of e. So you can't have a natural log to the base of 12. You just can't. And finally, if not explicitly defined, if you don't see a number next to the log, always assume or understand that that base is 10. Okay? Woo! Well, now all your torture is over, isn't it? Well, or unless you like math. Thank you for watching. Good luck on all of your Good luck on all of your mathematical moments. I hope that you ace whatever test you're doing, or I hope this video helped you in any way. If I did something like ridiculous, comment in the comments. See you next time.